All right, so we are going to be talking about energy a little bit more today, and we're going to start out by talking about conventional energy. I know we kind of went through some of the overall energy needs last 2 weeks ago. Then last week I was down because I actually threw a rib out of place. That was fun. I will be seeing you for a short period tonight. It will be a short class because I'm going to put the lecture on here for you guys to watch, and we'll basically just have a short discussion about some dates and what to get done, and you will be free to go on your way. So, without further ado, here we go. Conventional energy. We've talked about energy, and we talked about a couple weeks ago the different kind of types of energy. We talked about some conventional. We talked a little bit about some others. We're going to talk about some basic energy resources today. These are more conventional sources. We talked about nuclear energy already. We will talk about some sustainable energy solutions. And sustainable energy might not be exactly what you think. But let's get into some of the energy resources. Right now, fossil fuels do supply most of the world's energy. Fossil fuels still supply around upwards of 70% of all the world's energy. And so that's something to kind of think about while we talk about we're moving away from different things, and hopefully you're researching your countries and finding out what they're doing. We're going to look at what the current sources of U.S. energy are and where we're kind of at here. Probably this will not come as a surprise to anyone. But when we talk about the world energy use, we look here, coal, natural gas, and oil. So you add those up, 34, 21, and so coal, natural gas, and oil. So we have some math wrong here. So 34 plus 21, we have 45% there. And then we have about another 25% up there in coal. So that takes us up to about that 70% number. It's probably upwards of a little higher than that. It's probably closer to 80% whenever we look at this. So 55 and 25, 80%. So what we then kind of look at is some of the other. We look at nuclear power at 6.4%, hydroelectricity 2.2%, biomass and refuse. That's kind of a growing portion there, but the problem with that is it still involves some type of burning process. Other renewables, things like wind, solar, those types of things. That's the number that you would think would be a little bigger. But less than 0.5% comes from those other renewables, and those are some of the ones that we're calling the sustainable energies that we'll talk about later. The math problem on the bottom you don't have to worry about too much, but that's the total megatons that we use in energy worldwide. So when we look at the U.S. is about right on pace with the world. We have 37 petroleum, 25, that's 52, that's 62. My math is terrible. Plus 21 is 83. So when you look at those, we are a little bit higher than the global average. We have about 9% nuclear, and only 8% of ours is renewable. And here's where the renewable comes. Again, we look at such a small amount as solar and hydropower, wood. That's kind of interesting. Wood, that's more of the pellets and things like that are used. So it's not just burning wood. It's more refuse and usage and things like that. So something to keep in mind in that regard whenever we're talking about it. So what does the U.S. use the energy for? Well, if you probably stop and think about this, the U.S. uses most of its energy for, I would have thought, transportation, but manufacturing and industry are the actual number one consumers of our energy, which also makes a lot of sense. But I would have sort of guessed that it would have been more transportation than energy, but that's probably based on my skewed vision of here in Kansas City. and what we have. So. Also, when you take a look here, residential and commercial then account for the other 40% that we have there. And this is by 2005, so this is a little bit of an old chart. However, nothing has really changed as far as these numbers and what we have. So let's look at coal, one of the more conventional energy sources that we still use a lot of. There are a lot of coal resources. The U.S. controls a lot of the coal resources. Coal mining is dirty and it's very dangerous, regardless of what you hear about clean coal and things like that. Burning coal does release many pollutants, and the coal technology could be helpful. Now, what we're talking about with clean coal technologies and what they mean is I did a lot of research and a lot of soul searching on this because I don't personally see coal as a clean, viable energy source. However, what they were talking about for this so-called clean coal and that initiative had to do with the scrubbers being put on the stacks after the coal is burnt and different things like that. So it's trying to trap some of those pollutants, those sulfurs, those dioxides as they come out. So we have different coal types here, and this is where it becomes kind of important to understand. The most desirable coal to burn would be anthracite coal. It has the highest carbon content, and it gets the highest heat value. This is usually found in northeastern Pennsylvania. We don't have a lot of it. There's only about 7.3 billion tons. The next one is the bituminous coal. This is the most plentiful coal that we have. It only has, in what we average, this is a broad range, 45 to 86% carbon. Most of it averages around 60% carbon. So you can see we get significantly lower BTUs out of it per pound. So that's a little bit of an issue and a little bit of a problem because that means that the less carbon in it, the more other waste products that there are. And whenever you have then those waste products, those become pollutants whenever it is burned. So that's sort of a little bit of an issue. Now we have subbituminous, and this is the coal that's only about 35 to 45%. You can see the heat value significantly drops. These are most of the coal that we have out west. It does have lower sulfur contents, and it does burn a little bit cleaner. But you don't get as much energy out of it, so it requires more of it. Then we have lignite, which is kind of the youngest coal that we have, or brown coal. This is actually, unfortunately, what is being burned for power generation. Because we have a lot of it, it's not as deep into the earth and everything like that. So as we burn it, we put a lot more pollutants and we get a lot less out of it. It is not very efficient. So kind of some things to think about on coal. Oil is our next one. The main thing that we have with oil is the resources are not evenly distributed. I think we know this. So when you think about it, a lot of times when we think about oil distribution, we think about the Middle East. We think about where a lot of the oil is. Like other fossil fuels, oil has negative impacts. One of the things that you're going to have a discussion about, one of your discussion boards is going to be about ANWR, which is the Arctic National Wildlife Refuge, and whether you think we should be drilling there or not drill there. So you're going to have to do a little bit of research. I'll put some articles up for you to read. We'll talk about that in class this evening. Then we also have these oil shale and shale oil, which involves the fracking process. Which is another article I'm going to put up for you guys to be able to read. It's kind of a pro and con of fracking, and that will be another discussion that we're going to have about it. And the tar sands, they do contain a lot of petroleum, but getting them out is a very dirty process that causes a lot of instability. So one of the things, this is talking about limiting production. This is the global petroleum production in billions of barrels, and you can see where we have gone and what it's done. I know none of you are old enough to understand the significance of 1973, but 1973 was kind of a tipping point that we had. You can see we started reaching peak numbers, and this dip that you see right here was the oil embargo that was imposed in the later 1970s. And that can be a problem because what we had in the U.S. was we had gas shortages. We had lots and lots of problems. This was in the mid to late 1970s. And there was a lot of energy problems going on at the time. And that's when the president of the United States was Jimmy Carter. And he is the first president who wanted to develop a long-term energy policy. Unfortunately, in the late 1970s, we didn't listen. And we moved forward, and we seen an increase in oil production, and then we started to see a decrease. Now, this decrease came about, and we started seeing some issues with other oil producing and exporting countries. That's OPEC, if you've heard of them. We started seeing some infighting and some different things like that to see different things. And we've kind of seen up and down and up and down. So is there a lot more oil to be discovered? 80% of the oil that we are harvesting is from oil fields that were discovered prior to 1973. So that is one of the issues. Then in the 1990s, the oil discoveries averaged about 7 billion barrels of oil a year, only about a third of what we were using. So we haven't really found new oil sources, and I'm not sure that there's a lot out there to find. The discovery rate of multi-billion barrel oil fields it hasn't happened since the 1960s. In 1938, fields with more than 10 million barrels made up 19% of all the discoveries. By 1948, that dropped 3%. So basically, the technology was out there. We found the oil. We know where it is. Whether we can get it out or not, it's kind of the issue. Oil discovery rates. So you can see here, this was when the Middle East kind of went through its heyday. You can see this is when we were discovering all the oil in the Middle East. And you can see how that number has significantly declined. We're just not finding new oil. You can see, 1938, lots of oil was found. Then we started, it kind of peaked, those oils in the late 60s, 1970s. And by 1980, which would be right in here, it curtailed and significantly dropped off. This is in billions of barrels being discovered over here. So the U.S. petroleum use, this is something that's interesting. Just kind of take a second to take a look and note these numbers and think about the years. I think it's somewhat interesting as to some of the things that happened. So as you've kind of taken a look at some of those, some of the things that I notice are right in here. We peaked in 2005 for a while. Then this is when we started seeing oil prices that jumped significantly, and gas prices were $3, $4, $5 a gallon. We've seen a drop. But then by 2009, when the so-called recovery effort was coming about, we've seen an increase. But what an increase in usage. This usage also went along with an increase in production. So global petroleum usage, this is some interesting stuff. It was estimated that we were using 87 million barrels a day. That number is upwards of 93 million barrels a day now globally. That's 31.8 billion barrels of oil a year, or we're basically going through about 1 billion barrels every 10 to 11 days. That's 1,000 barrels a second Think about that number. We're just burning through, pun intended, 1,000 barrels of oil every second. That just kind of blows my mind a little bit. The U.S. accounts for 25% of all of this. Keep in mind, the U.S. global population is less than 5%. We're 5% of the global population, but we account for 25% of the petroleum usage. There's a huge disparity there. The fantasies about oil. There are people that will tell you that America is sitting on top of a supermassive 200 billion barrel oil field that can potentially make American energy independent. Until now, it has largely gone unnoticed. Thanks to the new technology, the Bakken Formation in North Dakota could boost America's oil reserves by 10 times, giving Western economies the trump card, no pun intended there, against OPEC's short squeeze on oil supply, making Iran and Venezuelan threats irrelevant. While that oil field does exist in the Dakotas, this was at a time when oil was well over $100+ a barrel, and it was cost effective to pull that oil out of the ground. It costs a lot more to pull it out than OPEC has, because you have to put in a lot of different technologies to get it out. Since oil has dropped, we have stopped a lot of that process of getting that oil out because it's not cost effective. So even if we talk about 200 billion barrels at 20 million barrels a day, that gives us only about 27 years of oil. So the problem is to get this oil out, if only 10% of that is recoverable and cost effective to get out, now we're down to less than 3 years of oil that we have on our own. Now that's a good reserve to have, but that certainly wouldn't get us very far. Also, this Bakken formation is a very tight formation, and what that means is the rocks are holding it very, very tightly, so it takes an expensive process to get it out. This is where fracking and horizontal yields and drilling would be necessary. There are also the Canadian oil sands that have about 170 billion barrels, and the current production is about 1.2 million barrels a day. But even that 1.2 million barrels a day doesn't get us through about maybe an hour and a half of use in the U.S. So most of the world's known natural gas is in a few countries. So we move on to natural gas. We already had the discussion of how natural gas is formed and how it gets there. The U.S. is one of those countries that has a lot of natural gas, and so does Russia. Has a lot of that natural gas. And it could be used for a lot of different sources. We also have gas hydrates. These are hydrocarbons that are trapped in water molecules. They freeze, and when they do, there's a lot of this natural gas that could also be frozen in the ice shelves in the Arctics. But this could be playing a huge role in climate change. Also, as they start to get released, does that natural gas get released into the atmosphere and cause a bigger problem is something we don't yet know. Nuclear power, we've talked about how nuclear reactors work, of it being a fission process where we split those atoms apart, and we do create there are different reactor designs, but right now we don't have a lot of new ones being created. We don't have the safe radioactive waste storage, and decommissioning them can be a problem. So the fortunes of nuclear energy, we've talked about it with the disasters that have happened with Fukushima in Japan. Some of the others, I don't think we're going to see nuclear cars, airplanes, or trains, unlike Back to the Future predicted. So we had a long-range energy plan, and that long-range energy plan was put in place by the Clinton administration. However, it was also predicted that we would have fusion power and all kinds of other things. We haven't met a lot of those long-range energy plan goals, and as long as we keep having a tumultuous political environment, we probably will not become energy independent anytime soon. So that's the first part of the slideshow. I will be recording the second part, which is sustainable energy, very, very soon, and being today, and I will put it up as soon as it is done.